Hi, my name is Roger with CoderU, and in this video we're going to be discussing ES6 and its greatest hits. So ES6, in my opinion, has been kind of a bit of a turning point in JavaScript in its history. A lot of people have complained that ES6, or actually JavaScript prior to ES6, wasn't very object oriented. It's not a real language. There's a lot of arguments made against JavaScript, and some people were kind of made fun of as JavaScript engineers. However, with the advent of Node.js and ES6, it really allowed JavaScript to shine because it introduced a lot of the same functionalities you see in many modern languages like C# or PHP. So let's kind of dig in and see what ES6 actually introduced that kind of changed the fabric of how JavaScript is coded today. So JavaScript ES6 brings new syntax and new awesome features to make your code more modern and more readable. It allows you to write less code and do more. ES6 introduces us to many features like arrow functions, template strings, class destruction, modules, and more. So let's take a look. Constant is a new keyword in ES6 for declaring variables. Constant is more powerful than var. Once used, the variables can't be reassigned. In other words, those variables become immutable except when it's used with an object. So this is very important because prior to ES6, you can see here they have an example where they use var. My button in this example can be reassigned over and over again. So it allows, it's a bit of a security concern, a security issue, if you're able to reassign these values at any point. So the introduction of const really allows it to protect the variable itself and stop people from being able to inject values into these into the code. So along with constant or const, also introduced let. Let is like var. It allows it to be reassigned and take on a new value, which is a mutable variable. So let is the same as const in that both are blocked scoped. It means that the variable is only available within its scope. The next big feature that ES6 introduced was arrow functions. So arrow functions is really awesome and makes your code more readable and more structured and look like modern code. Instead of like using this, so they use this code example in ES5 where they declare a function and then return hello with concatenating the name. Okay, what that has become is that's become here where they define a const myfunc variable, so that way it makes myfunc immutable. And what arrow is this real syntax right here, where they do the equals greater than sign with a block scope here, and then they're returning something. And this is what they mean by a template literal. What they're doing is they're using a single quote, and then in template literals, rather as opposed to concatenating, using ES5 where you have to end the string and then use the plus to say you're concatenating a value, you can basically use the $sign curly brace to inject that variable into the string itself. So you can see here they define the arrow function that takes a parameter called name, and they're able to pass sed. So it'll say hi sed when it gets outputted. Now with what's cool with arrow functions is you can even break it down even further. And if you have syntax like this where it's just simply the curly brace and a return statement, you can get rid of those and just say name, the parameter, the arrow function syntax, and then the literal string, the literal template, which is in effect the very same thing as going up here to the ES5 syntax. So you can see how the difference, how the code is cleaned up between the ES5 style function declaration versus how how much less code you have to write when doing the same thing. So, and this really works well with working with maps and filters, reduce functions. Now let's kind of jump over here as an example of when not to use arrow functions. So here I have a class that's defined that says book. It's a class called book, and I'm setting a title. So I'm basically passing in a parameter here, and I'm storing it within itself. So we'll use set timeout as our test function to show why arrow functions isn't a blanket replacement for functions and when it is. So here we're using an arrow function to basically say we want to export out, or not necessarily export, we want to display what is in the title variable of book. Okay, so we'll actually say set timeout, we'll declare the arrow function, and then we'll say console log, and then use the template string exporting the title variable from the class that we define in the constructor. The next test we have is where we're just using a plain function here to basically export this title, the same variable, out in this manner, where we're just kind of defining it as a function. Now, the last test is what we're doing is we're actually doing the same thing, but in the previous function where we're kind of just exporting it with a function, but in this sense we're adding bind this to the function itself. So when we go and export this out, we go ahead and run this code. You see here, okay, in the first test where we're exporting the title here, where we run get title on the class, we do get the value, okay, which is standard. I mean, we're not doing anything special there. When we do the arrow function, you see that the arrow function has access to the value which is of book. Okay. However, when we use the function itself, here you see we lose scope of that value, of the context of what we're discussing, of what we're talking about. Because what happens is function creates a new scope in itself, and that creates the issue here. Whereas in the last test, the bind function is basically the ES5 equivalent of the arrow function, because we're basically taking that function and we're saying bind this, or the class itself, the instance of the class, to the object. Okay, so where this can be an issue also is, let's say you're defining an object with a anonymous function in it, and in that anonymous function, if you declare it as an arrow function and you're saying you want to reference a variable within the object, you're going to possibly lose scope of that. So let's kind of test that out a little bit here. So we'll say constant object equals value true, get value. So let's say we just want to return this dot value here. Now let's kind of go with the ES5 method of doing it. So we'll say return this dot value. And now let's go ahead and like display something here so we can see what it looks like, what we find out. Object dot get value. Now let's go ahead and also export the ES5 equivalent of that. So now, as you can see here, in the anonymous function declaration that we have, it showed that it was undefined. It did not find the value this dot value. However, when we defined get value as a function itself, we were able to access this value that we defined in the object. So that would be another instance where you might not want to use an arrow function if you want to be able to do this kind of programming. So as you notice here, what we're doing, I'm using this in Node.js 4.9. So to show you that even going all the way back to Node.js 4.9, we were still able to use this style of syntax using arrow functions for quite a while, ES6 style functionality. So let's kind of move on. So next up is template literals. Template literals is a very awesome feature, which basically helps you reduce your code and, really clean it up. You might have already seen it in a couple places in this video. And as you can see here, we have two examples of the same code, okay, where we're doing the exact same thing, where we're substituting two values into a string. So this itself, the template literal is basically an open single quote where we have the string, and then in the string we're placing the variables with $ curly brace surrounding it to tell the interpreter that we want to place a variable in this location. Now, variables aren't the only thing that you can put in here. You can also put conditional statements, inline if statements. You can call functions, as long as you define this $ curly brace around the JavaScript that you're trying to execute. So another big change in ES6 was the introduction into default parameters. Default parameters is really big. I experienced this as well in PHP. PHP was the language I started off in, and default parameters was great, in an object-oriented manner where you can basically make parameters optional. Here we have an example where they're saying they're creating a function with two parameters, name and age. And what they're doing is they're basically only passing in the name. They're basically passing in sed for name and then not defining age. So what you see here is when they output the string, you see it says, hello sed, your age is undefined, because we never actually set it, or we never passed it in the function. However, if we set in a default value for age in the function definition, you can see that when we ran the same code, it set 22 to age even though we didn't pass it. So that's really where default values can tend to help. So after that, next up is object and array destructing. This is a very cool, also another very cool feature of ES6, because prior to ES6, whenever you want to export values, like let's say we're not using, this is not quite true because ES5 in this example didn't have const or let. So that was an ES6 feature. So imagine this was actually var, everywhere var. But if you wanted to extract or explode some of these values into separate independent variables, you'll have to do like this, where you define the variable var name, and then you'll say contacts.name. Okay, which this kind of programming can take up. It's not very clean, not very readable in a sense. So in ES6, you can see here where they did the constant declaration for the object, and then they basically exploded or destructed this object into independent values. So name here sed became name outside, because that's basically what object destructing does, is it defines, it takes that value, that object value inside the object, and takes it outside of that object, so you can reference it. So you see here they logged out, they showed name, family name, and age. Now keep in mind too, like you can have more than just what you see here in this object. So you can have enabled family name, middle name. You can have a fairly large object defined here, but then only destruct the values that you need. And this is very useful when you're defining, let's say, a function as well. Like if you're passing an object to a function and you only need a subset of the values in that object, you can destruct the values so that way in the function itself you're able to use those values without having to go back the ES5 way and like set them as independent variables. I'm going to actually jump around a little bit. The article kind of splits up. The next thing I'm going to talk about is rest parameters and spread operators, which kind of seems like a next logical step after discussing spreading or destructing. So rest parameters is when you're able to get the arguments of an array and return a new array. So here I have an example that I don't really see. We'll kind of talk through this example here that they have. What they have is they actually have an array that they defined, and in this array they have 1, 2, 3, 4, 5, 6 elements in this array. So when they do rest parameters, this is also a bit of like object destructing as well, where they're basically assigning sed to value 1, 20 to value 2, and JavaScript enthusiast to value 3. Now, spreading is whenever you have these 3 dots here. Okay, they're basically saying whatever else is in this array, assign it to rest, to the rest object. Okay, so then whenever they pass rest to this function, you see they add a filter where they're just taking item and they're returning it. This is basically, in essence, they're returning non-null values or non-false values, because if you had, let's say, a 0 in here or false or null, filter would remove those elements from whatever is remaining and then concatenate it together, which in this sense, when they output it, it would say, hi, said, how are you? Question mark. Because those are the last 3 elements that we didn't destruct in our declaration. So a really good example I have put together over here of rest parameters is we'll go ahead and define an array with A and 1. Okay. So what I'm doing is I basically I defined a function here that says we're passing in ARR. Now, this is not the same ARR as from the outer scope. This is overriding ARR with its own version, its own scoped version of that variable. Okay, so if you take a look here, we'll output. We do console log output func, which you see here is how we defined it in the array. Now, inside of this function, what we're doing is we're incrementing this 1 to 2. So then you see we output again the array from inside the function. You see now we've incremented it. But because we passed the array itself as a value, as the object itself, it does a sort of, how do I say, basically it's like a pass by reference. So when this object or this function returns, it doesn't return anything, but you see when we go to output that array again, the value inside of the array has changed, even though it's outside the function. So even though we scoped it inside, it still changed. Now let's use spreading here to basically say what we're going to do is we're going to spread the values A and 1 to this function here. Now what this is going to become, this is going to be the equivalent of basically saying func A, the first parameter is going to be A, then the next parameter is going to be 1. Now what we did over here in this function declaration is we basically use the rest parameter to group those values back into the ARR variable. Okay, so then we're doing the same test here inside. We're incrementing the first index, or the one index of the array, and then we're outputting it. So now you see here, we incremented it. Then when we came out of the function, we again displayed the array, and you see now that it did not hold. It did, because the scope, because the it did not send the variable by reference, which is very important and very useful. That's what it means by using REST parameters. Okay, now the next part of this section is using spread operators. And spread operators is really useful when it comes to like trying to inherit an object. Okay, so for example, we're using access controls here. We have our default user role, we have a user manager role, and then we have a user engineer role. Okay, so let's say we define a user, a constant user. This is the default user role. Now let's suppose that this user then is promoted to an engineer. So the way we can do this, we can inherit, we can basically tell it, hey, create this new engineering variable based on the values within user. So we're exploding. So name becomes its own. Everything that was in default user role, which would be these values here, become an element in the engineer. But then because we're passing user engineer role, which has these values in it, okay, this is going to override the default user role that was defined within user. Okay, so when we kind of jump down over here to the example, you can see when we outputted, because what I did over here at the end is I took each element, each section, and I outputted the user by itself, outputted engineer by itself. Okay, so you can see John has in this user role, has the user role itself, but in this engineering variable, he has the user role of engineer. And the same thing would be applied when we do the same thing for manager. See, in ES, prior to the spreads, because these object spreading, I've kind of come across a bit of hit or miss on these values, because I've seen, because if we go over here to object destructing within Can I Use is a great resource to see what browsers support these functionalities. So now, even though ES6 was implemented earlier within, like in around 2016 in this instance for, let's say, Chrome, or 2017 for Firefox, ES6, just because it says ES6 was implemented during these times doesn't mean it was a full implementation. So object destructing itself was implemented, let's say, in Chrome in 2017, mid 2017, and late 2017 for Firefox. So you can really help yourself out if you're wanting to kind of support and make sure you cover your bases when it comes to using these type of functions. If you want to make it backwards compatible with older browsers, you can use transpilers like Babel. I'll have a link up to the Babel video for those that are interested, up in the upper right corner of the video. But back to our example here. So in ES6 allowed us to use object assign. This is basically the equivalent. So object destruction like this, where we're inheriting values like this, I found seems to come from ES9. Okay, when I looked up ES9 specifically, it said that it allows us to do this style of inheritance. In Node.js, if you actually take a look, I set the runtime for this example to the earliest 4.9. Well, I mean, you can try Node 0.12, but 0.12 didn't have Well, actually right here. Yeah, in our example here, you can see that it did not have the ability to do this style of inheritance in 0.12, but starting in in 4.9, we did have this functionality where if we rerun it, so depending on what platform you're wanting to target, whether it's Node.js will have these features already enabled, whereas in browsers you might need to do transpiling to get that to work. So back to our article. So another good thing about also that I forgot to mention here in our example is when you do object or variable destruction, you can rename the role variable to a different variable name. That way, if you, let's say, have conflicts in your variables, if you have another variable named role within the scope, you might want to rename this to something like user role, and then you can start using that new variable in your code. It'll have the same values as was defined in the outer scope. So next up, we'll be discussing import and export. So this in itself is a bit hit or miss, especially in Node.js. Node.js specifically uses CommonJS. So for the longest time, it uses CommonJS style importing, where you're basically writing code like this, where you're saying exports.name, exports.add. But in ES6, the point of ES6 import exports is you can say export default. So whenever you say import this file, this detail will be the first thing that comes out. But thing is, and you can see here that they actually use that import detail from that component. Or if you define, let's say you do multiple values, they don't actually have it defined here, but let's say you do more than just detail in here. You also define export constant user profiles or export function get post. You can basically import the values or the variables you need from within this this component. So let's jump over here to this other article by CodeGus, which talks about import and export in Node.js. So Node.js hasn't really implemented by default ES6 style import exports. So you see here, now whenever we have to use a value within Node.js, we basically say we require the file into calc. Now we can definitely use object destructing in ES6 to basically only inject the values we need. But if we just constant calc, it's going to import every one of these components into the script. So then you have to say calc.add, calc.subtract. So in ES6, what it allows us to do is do export const name or export const add, which allows us to use arrow functions to define a function for this this variable to export. So then whenever we go to ingest or import these values, we can say import asterisk, which basically means import everything into as calc, which is basically what they're showing here is this code and this code are equivalent. They're basically behaving exactly the same. Now, what we could do is, let's say we don't need everything in this class, in this file. We can say import curly brace add, comma, subtract, comma, multiply, or multiple. And we will only import those three functions into our code base and then leave the rest outside. Don't import it. But the problem is, because Node doesn't implement ES6 by default, with the import export, it still uses CommonJS style require and even up to the newer versions of Node. However, you can gain this functionality if you were to use Babel. If you were to implement Babel, oh, and just to note also, you can enable this kind of functionality in Node, but it requires you flipping a flag within Node in the runtime of Node and renaming your JavaScript from, instead of JS, it'll become .mjs. So, but in the meantime, for handling older Node versions that might not have this functionality enabled by default, then you can use Babel to transpile these statements to the old school require and require statements. So what'll happen is when Babel runs, it'll take this code here and translate it into this style ES5 code, which will allow Node to interpret it without having to enable any special functionality. So as you can see here, they actually took this, ran it through Babel after installing the necessary, see, because that's what they did up here at the beginning in the package.json, is they included the Babel dependencies here, then created a Babel RC file within the project directory that says that we're targeting ES 2015 and Node 5. Okay, so which is basically, it does what I said, where it's going to convert these export import statements into this style of older code. So next up, we're going to be discussing promises. Promises is really cool too. The next evolution of promises was async and await implementations, which I created another video. I'll link that up as well, which basically promises has been implemented by several third-party libraries. You might have heard it, like Bluebird was a very common one. But ES6 implemented promises by default, so you don't need any extra libraries in order to gain this functionality. And promises basically allows you to perform asynchronous code, because what it does is whenever you execute the promise, you're basically passing a resolve or reject. So that way, when you run, you can tack on then statements to the end of your promises. So like in the example here, they're using get data. They're defining get data using fetch. Fetch returns a promise. Okay, so when they say get data the URL, they're using then to say after we've retrieved it, we'll go ahead and convert that to JSON. Then we're going to daisy chain, and after that's converted to JSON, then we're going to output the results of that. Now the problem is whenever you use asynchronous code, what happens is when you run this, okay, your code is going to continue on until the asynchronous call is completed. So then it loses scope of the execution of where it's happening. If you really want to dig into more about this, I highly recommend looking at my asynchronous async await video that I'll link up in the upper right corner. So we've already covered REST parameters and spread operators earlier. So next up, we're going to be discussing classes. Classes are the core of object-oriented programming, and they make your code more secure and encapsulated. Using classes gives your code a nice structure and keeps it oriented. Classes are really good because it really, like I mentioned earlier, it brings the language itself up to par with that of, let's say, C# or PHP. You can do private and public variables, and we're actually going to use our arrow function example to kind of demonstrate that. So for example, let's go ahead and say, like, if we were right now to say we change this to book.title here, we're going to export that out. You'll see that we have access. This is a public variable. You know, even though we set the title inside the variable, it is very much viewable from outside the class. But let's say you wanted to change this to instead be a private variable. You would say something like this, get title, and then you would say return, use the arrow function, title. Now, everywhere that we have it referenced, we would say get title. Now, we know that this won't work, so let's leave that one alone for now. That'll just stay undefined. Okay, so now let's change this. Now let's rerun it, and what you'll notice is now it says book.title is undefined, but now our arrow function timeout here still has access, and our bind function call still have access to the title itself, because we scoped it. We basically, in essence, created it as a private variable which cannot be accessed from outside the class. So that's pretty much it for this video. If you like what you heard, please like the video, subscribe to the channel, and I'll see you next time. Have a good one.